Section 5.3 is about graphing inequalities in two variables. So up until now we've been just dealing with inequalities that have one variable. So something like 2x is less than 4, and then we solve that and we've been graphing it on a number line. Now we're going to do just like we did with equations, where I'm going to have something like y is less than 2x plus 4. So now I have two variables. I have an x and a y, and we're going to graph them on the coordinate plane. So instead of a number line, we're going to graph on the coordinate plane, just like we did with equations. So when we do this, we have 4 steps. Step 1 is going to be to solve for y, or get y by itself. So just like we did with solving equations, I can't graph this until I get y by itself, until I get it into slope-intercept form. And the only difference this time is, instead of an equal sign here, instead of y equals mx plus b, I'm going to have y and then some equality. So y is less than mx plus b, y is greater than mx plus b. So if we look at this example, 2x plus y is greater than negative 2, I need to get the y by itself. So I'm going to subtract 2x from each side. Okay, so then I have y is greater than, no big but because I subtracted, I didn't multiply or divide, negative 2x minus 2. So I have it in slope-intercept form, ready to graph. For step 2, I need to decide whether it's a dotted line or solid line. So just like when we did graphing on a number line and we had to decide a filled-in circle or an open circle, the same thing applies here. So dotted line means the solution is not included, so that would be greater than or less than. And a solid line is like a filled-in circle. It means the solution is included, so greater than or equal to, less than or equal to. So if we look at our example, we have y is greater than negative 2x, so it's going to be a dashed line. So when I go to draw my graph, I'm going to do my points just like with an equation, but I'm going to connect them with a dotted line instead of a solid line. So my y-intercept is negative 2, so there's my first point. And then my slope is negative 2, so remember that's negative 2 over 1, so I'm going to go down to right 1, down to right 1. Or I could go up to left 1, up to left 1. Okay, so then I have my points, and instead of drawing just a straight line like we've been doing, I'm going to draw actually a dotted line between these 2 points. Okay, so it's going to look something like that. The reason we have to do that is any point that is on the line is not going to give me a true answer for my inequality. Okay. Anything that's greater than above this line will make this true, but anything on the line, it won't be true. So I make it dotted to show that the things on the line aren't included, just everything above it. So then for step 3, we have to shade the rest of the grid, because remember, for an inequality, there's more than one solution. So it's not just the line, it's everything else. So if it is greater than, we're going to shade above the line. If it's less than, we're going to shade below the line. So our example, y is greater than, so I'm going to shade everything that is above that line that we drew. Okay, so what that means is any point up here in this shaded area makes this the inequality true. Any point on the line or below it will not make the inequality true. All right, and that is actually step 4. We're going to test an ordered pair to verify that we've shaded in the correct direction. Okay, so I need to pick an ordered pair that's in this shaded in area somewhere over here that I could plug into the inequality and see if it's true. If your line does not go through 0, 0, that is the easiest one to pick as a checkpoint, because it makes the math really easy when you plug it in. You could pick anything you wanted. 0, 0 is going to be the easiest. So if I plug 0, 0 in, it would be 0 for y and 0 for x. So I would have 0 is greater than negative 2 times 0 minus 2. Okay, so if I simplify this, 0, 0 is in my shaded solution, so it should give me a true statement. So 0 has to be greater than negative 2 times 0, which is 0, and 0 minus 2 is negative 2. Is 0 greater than negative 2? Yes, I got a true solution, so I shaded the right way. Okay, now I just want to show you what I'm talking about with the line. So if I picked a point that was on the line, so let's say this is 0, -2, right? If I plug that into the inequality, I would have y is -2, so -2 is greater than -2 times 0 minus 2. So -2 is greater than, -2 times 0 is 0, minus 2 is -2. -2 greater than -2. That's not true, okay? This isn't right. It's not true. -2 is not greater than -2. Okay, so that's why the points on the line aren't included, and then anything over here also isn't included. All right, we have one more question here. 6x plus 5y is less than or equal to 20. I want you to solve this and then choose the correct answer, and you're going to put that answer on the Google form. So A, B, C, or D, whatever you think the right answer is, that's what you're going to put on the Google form as the answer to the question. And then that is all. We will learn how to do these on the calculator when you come to class.